Hello and welcome to the Friday, July 26, 2024 edition of the SANS and Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. Got a quick analysis of some current malware from Xavier. Xavier looked at a sample of XWorm. XWorm is a relatively new malware family. It's a remote access tool and has recently been used quite a bit. It's actually a .NET executable, at least a sample that Xavier got his hands on, and it's not obfuscated. So in order to analyze this file, all you need is to simply disassemble it. Once disassembled, Xavier talks you through some of the steps taken in order to figure out what the sample does, like how to identify, for example, the embedded PE file, and then which process it will actually attach itself to. XWorm performs classic process hollowing, where it first starts a process, suspends it, then wipes its memory, and then essentially just allocates new memory that will be used to run the malicious payload. This is often used to bypass various endpoint protection systems. Exfiltration in this case, as Xavier shows, is happening via Telegram. It uses the standard Telegram API to exfiltrate data. It's also a common technique seen in different malware families. Restricting outbound Telegram traffic certainly makes sense for most organizations. Of course, some of you may use Telegram for business purposes, but I don't think that's all that super common. Joe Leon with Truffle Security published an interesting and somewhat concerning blog post about how to access deleted and private repository data on GitHub. The problem shows up if you fork a public repository, then you make changes to the fork, and then later delete the fork after you committed the changes to your fork. So all the changes appear to be just located and linked to your fork of the repository, but the data actually is still accessible to anybody with access to the public repository, which of course is. So it's yet another case where data is not actually deleted whenever you click that delete button. The problem is in particular, and that's sort of one thing that Joe does show here, if you are forking a repository and then you're making some personalized modifications to it. For example, you're adding an API key, you commit it, and then later you delete that forked repository. Those API keys, they are now accessible to the public. Now, before you ask if GitHub fixed that bug yet, well, according to GitHub, it is actually not a bug and that behavior is documented. It says here in the important security consideration section that commits to any repository in a fork network can be accessed from any repository in the same fork network, including the upstream repository. So that at least clarifies that an upstream repository is able to access commits in forks made from that upstream repository. Doesn't quite explain the deleted part, but since these commits are already sort of part or owned by that upstream repository, that's, I guess, why they're not being deleted. A similar issue shows up if you fork a private repository and then make that private repository public, which then means that the fork is also public by association with that public repository. Now, Truffle Security is the company behind TruffleHawk, the secret scanning tool. And of course, that tool is now incorporating features in order to scan for secrets left behind in these deleted forks. In recent years, browsers have implemented some anti-malware filters in order to protect users from malicious files downloaded via the browsers. The obvious workaround for attackers was to make these files password protected. Once password protected, the file is no longer scannable by the browser or the infrastructure behind the browser. So that way these malware detectors were bypassed. Well, Google Chrome is now experimenting with an extension to its Google Safe Browsing feature. Whenever you are downloading a password-protected file, the browser will prompt you for the password, which will then allow the anti-malware engine to decrypt the file. Of course, this will require that the file as well as the password is being sent to Google's engine, and that's where the scanning for malware will actually happen. Users are also able to just select download anyway, and that way there's no password required and the file will download as before. Sounds like an interesting feature. Not 100% sure about the privacy implications here, but since that's only an option, I think it's a nice welcome addition. Well, and that's it for today. So thanks for listening and talk to you again on Monday. Bye.